There we go. All right. Got it? No?
On number 6, that says XE to what?
Third.
Third.
Mm-hmm. It's just that E is distributed, that's all. If you'll remind me before class is over, I have some papers, some older papers to pass out. And it's not for everybody, it's just like people who took tests late or something on a day other than when it was given. I have papers for you. Alright, there's 15 to 20. Are we done with these? No? Okay. I'm going to try to write in pen today so it shows up better when people are watching this later, which Trenton's the only one that's going to be, maybe going to be watching it. But then if I mess up, it's going to be a whole bunch of scribbling. So that'll be good to try and read on YouTube. Alright. Solving exponential and logarithmic equations. Is this your next page? Awesome. Okay, so the process for solving an exponential logarithmic equations are actually, they're very similar to each other. Okay, we're going to write out some steps here. If an exponential equation has only one exponential expression, so basically what they're meaning is like it's a base raised to a variable. Okay, so like right, what this means is a base raised to a variable. That's impossible to say. Zoomed out too far. And that's it. It will not zoom in. Sorry. That's it. I'll just hold it like this and write on it on the palm of my hand. No problem. Yeah. Okay. Yeah. I guess I could put a book or something under it. Alright. So, first of all, the first thing you do is isolate the exponential expression. Yeah. Ooh, I don't know. Maybe it's out of focus then. Yeah, that works some. How's that? Alright, so I'm just going to say I'm not writing the next word because it's made up. But I'm just going to say take the log of both sides instead of logarithmitate. We're going to take the log of both sides, okay? Logarithmitate? Almost sounds like something you shouldn't do. I'm just saying. And then you solve the remaining equation for x.
Like something you'd have to be like 32 to do. Like, you know, 18 you can buy cigarettes, 21 you can drink, and then 32 is like logarithm, whatever that word was.
I can logarithmitate, yeah.
Logarithmic.
Yeah, no. Alright, so see, right here, we have only one that has an exponent, right? I have one. So I can isolate the exponential expression. So that would be 2 to the 3 minus 2x equals 8. Then you can take the log of both sides, or you can just change it back into a logarithm. So let me show you what I'm talking about here. You've got two choices on a problem like this. You can say, all right, log of 2 to the 3 minus 2x equals log base 2, of 8. And see, this one goes away, and you're just left with 3 minus 2x equals log base 2 of 8, right? Because log base 2 of 2, remember those sort of like cancel out, sort of. But if you look at it like this, if I have 2 to the 3 minus 2x equals 8, if I rearrange this back into a logarithm, is it not a capital, is it not log base 2 of 8 equals 3 minus 2x? Which, is that not what I ended up with after an extra step? So, not always possible to go straight to that step, but if it is, just go straight to that step. Sometimes you have to take the log of both sides. We'll look at one of those in just a second. So this turns into log base 2 of 8 equals 3 minus 2x. Does anybody know what log base 2 of 8 is? 3 equals 3 minus 2x. Well, this one's easy. 0 equals negative 2x, so x is 0. That's so easy. See if I have enough color, I can change things up. And I got pink. Alright, if it has an exponential equation, or an exponential expression on both sides of the equation. First of all, you want to try to rewrite each side. Rewrite each side as a single exponential expression. With the same base. Guess what your next step is? Logarithmitate. Yeah, I can't even. If you want to write it in your notes, you can. I'm not writing logarithmitate.
I just spell that.
Logarithmitate. Sound it out. Hooks on phonics. You can do it. Logarithmitate. Logarithmitate, yeah. I'm just going to say log both sides. And then, step 3, solve the remaining equation for x. This is one of those. This is an example like this pink one that I just wrote out. I can make each of these have the same base because the base of 2 is, or the base of 8 is 2. So this turns into 2 to the third times x minus 1 equals 2 to the 3x plus 4. Or 2 to the 3x minus 3 equals 2 to the 3x plus 4. You can take the log of both sides. You can do log base 2 of 2 of 3x minus 3 equals log base 2 of 2 of 3x plus 4. And that cancels your logs out. I'm about to run out of room, and I'm using an ink pen, so I'm going to skip that step. But here, I'll just write it down over here. Basically, what you're doing is you're saying log. So whatever you do to one side of an equation, you have to do to the other. Okay, so that's what you're doing. And then these just sort of go away, and you're left with 3x minus 3 equals 3x plus 4.
So, no solution?
No solution. They're not all no solutions, just this one's no solution. Alright, if none of the above can be done, if you can't isolate the exponential expression, if you can't write each side as a single exponential expression with the same base, you've got two choices. You can try to factor and set it equal to 0, or you can graph it and solve it on your calculator. Alright, so here we would start off dividing by 3. So I have e to the 2x plus 1 equals 4. Since I'm dealing with e, I'm going to take the natural log of both sides. Natural log, natural log. These go away, and I'm left with 2x plus 1 equals the natural log of 4. Oh, this. Alright, subtract 1, subtract 1. 2x equals natural log of 4 minus 1. Divide by 2. X equals natural log 4 minus 1 divided by 2.193. That's what that equals. I'm not going to do another one of those. Look on the next page. Let's do one that's a little bit more involved. That was my little clippy thing, wasn't it? And by the way, I'm going back to a pencil on this one. Okay. right here, I can't do the first two things. I can't make this look like 1. I can't make it the same base. Can't do any of that. So I'm going to try to factor. Okay? I'm going to try to factor. This is factoring just like a quadratic, because this is quadratic form. Remember, anytime that this is half of that, you're looking at, even though it's not a quadratic, it's in quadratic form. So you're looking for two numbers that when multiplied equal a -5, but when added equal a -4.
-5 and 1.
-5 and 1. So you have, it's going to factor out to e to the x minus 5, e to the x plus 1 equals 0. You know who I feel bad for? All those poor Algebra 1 students who are like struggling so bad with factoring right now. And they're like, last night at church, they wrote their homework and they were working on it and they kept asking questions. Like, I'm so ready to be done with factoring. Hee hee hee.
Joke's on you.
Yeah. Sorry. That's never going to happen. All right, so e to the x minus 5 equals 0. E to the x plus 1 equals 0. So that means e to the x equals 5, or e to the x equals -1. All right, I'm going to rearrange this back into a log. Just flip it around, okay? Since it's e to the x equals 5, it would be the natural log of 5 equals x, and the natural log of -1 equals x. All right, you remember what I said about this one yesterday?
Oh, yeah,
Can't be negative, so that one's out. Sorry. This one, let's see, what is the natural log of 5? 1.609. Right there. All right, so on this one, you can't use any of those steps that we just talked about. Okay, this one you have to just try to take the log on both sides and do some multiplication and some factoring and some fun stuff. I'm actually going to use natural log. You can use either one. I just like to use natural log because it takes less to write it. It takes up less space. So that's what I use. So whatever you do to one side, you have to do to the other. When you have like this equals that, there's nothing else I can do with this. So I'm just going to take the natural log of 2 to the x plus 2 equals the natural log of 5 to the x minus 3. Now, do you remember in your little properties that we did, what happens with these? What happens with an exponent in a logarithm?
Oh, yeah, it goes in front.
Goes in front. So that's x plus 2 times the natural log of 2 equals x minus 3 times the natural log of 5. Now remember, when you're solving something, your goal is always to get the x by itself. You want to isolate your variable. So what I'm going to do, this is my plan. I'm going to fill you in on the plan before I start on it. I am going to gather all the x's on one side, put everything else on the other side. And then if every term on one side has an x, I can factor the x out. And that will help me isolate the x. So I don't know if you know this, but you can do distributive property with logarithms. That's x natural log 2 plus 2 natural log 2 equals x natural log 5 minus 3 natural log 5. That was just distributive property. And let me also say again, you could use just log if you wanted to, but see how I'm already out of space? That's even like one more letter written 4 times. So that's why I chose natural log. There's no mathematical reason behind it. That's what I'm telling you. You could, if you like common log more than you like natural log, go for it. I don't care. All right, so I'm going to get all the x's over here on the left, and I'm going to get everything else over here on the right. So this is going to be x natural log 2 minus x natural log 5 equals a negative 3 natural log 5 minus 2 natural log 2. Does everyone see how these came over here and that guy got over there? I just subtracted and subtracted. That's all. So now look, both of these guys have an x, right? So I'm going to factor it out. Put x. That leaves me with natural log of 2 minus the natural log of 5 equals negative 3 natural log 5 minus 2 natural log 2. Now what can I do to get that x by itself?
Divide each side by natural log of 2 minus the natural log of 5.
Right. X equals this negative 3 natural log 5 minus 2 natural log 2 divided by natural log of 2 minus the natural log of 5. That's what x equals.
That's really ugly.
It is hideous. And you better be pretty dang good at using parentheses if you're going to put this in your calculator, which is where it goes next. Start off with a set of parentheses. We're going to put all of this in parentheses. Your calculator is going to want to put these in parentheses. Then we're going to do a division, and then all of this will be in parentheses also. That's a lot going on. Alright, so I have negative 3 natural log 5 minus 2 natural log 2 divided by natural log of 2 minus the natural log of 5, 6.782. I want everybody to see if you can get it in your calculator, and if you don't get it in your calculator, then we need to see what buttons you're pushing incorrectly to get it into your calculator.
6.782.
Yeah. There's only 17 sets of parentheses there. Get it? If you didn't get it, did you figure out why you didn't get it?
I was told that the natural log was somewhere else.
Was somewhere else?
Yeah, it was the clear button. It just cleared everything.
Did you think to look for yourself where the natural log button was?
I knew it was. I was just.
Oh, okay. Okay, next. Let's look at a logarithmic equation. So, these are kind of the same. If a logarithm equation only has one logarithmic expression, isolate it. Now this is a real word. Maybe that's why they said, I don't even remember what the word is now, logarithmitate? Oh, because exponentiate is a real word.
You said logarithmitate.
Yeah, exponentiate both sides using the base of the logarithm. And then solve what's left. We don't have an example of this one. We have an example of the second one. So we'll do the second one and then we'll work the example. All right, so if a logarithm has a log expression on both sides of the equation, like this one right here, okay, rewrite both sides as a single logarithm. And, of course, use the same basis. Then exponentiate, and then solve. Okay, so addition means what? Multiply. So this is actually the natural log of x squared plus 2x equals the natural log of 8. That pen's not going to work. So I want to show you, just like in the last one, show you how maybe you could skip a couple of steps. So what's going to happen here is we've got the natural log of this equals the natural log of that, and we're going to make that e to the natural log of x squared plus 2x equals e to the natural log of 8. Well, what happens to these e's and natural logs? Yeah, they're gone. So we're just left with x squared plus 2x equals 8. Okay, so you can get from here to here just knowing they're going to cancel out, or they're gonna. So you've got x squared plus 2x equals 8, or x squared plus 2x minus 8 equals 0. It's going to factor to so x is negative 4, or x is a positive 2. Can x be negative 4?
No.
So x is 2. All right. Third thing, if none of the above can be done, graph it. Find the intersection on a calculator. In the end, always check to make sure. You want to check for extraneous solutions, but that may not be enough to write in there, because what makes it extraneous?
Negative?
Yeah, not always negative, but you need to make sure that no value of x causes the argument to be non-positive. That's what you need to check for. Always check to make sure no value of x. argument non-positive. That's what you're checking for. Alright, so let's try and solve some logarithms. What does that subtraction mean to do? Divide. So that becomes log base 2 of x plus 2 divided by x minus 1 equals 3. Alright, change that back to an exponent. What do you get? That's your base. 2. That's your exponent. So let's see, that's 8x minus 8 equals x plus 2. 7x equals 10. X is 10/7. What about this one? What can I do with this one?
You can put e in the natural log to cancel out.
Yeah, so I'm just going to skip to x plus 3 equals 2. So x is -1. Is that an okay negative answer?
Yes.
How come? I didn't think I could have negatives.
Because the
Plug in what 3 is 2.
Right. Right. Okay. What do I need to do on this one before I can get started?
add 3 to both sides.
Right, so that's going to be log base 3 of 2x minus 1 equals 4. And then how does that change back to an exponent?
3 to 4 equals 2.
Right. We're not solving that. I think you can solve a two-step equation. Let's get down here to these uglier ones, shall we? Can you see the pencil okay, or do I need to switch back to ink? Okay. I just don't like doing the actual math in ink. It goes against everything. We did one like this, so let's look at this ugly thing. Okay. Alright, so let's rewrite each side. Let's start there. So what's this side going to be condensed as?
Log base 2.
Alright, that's good. Everybody got that? Next.
X minus 3 over x plus 1.
Okay, equals.
Log base 2 of 3 is 7.
3, 7.
Alright. So then these two can go away, and you just have x minus 3 over x plus 1 equals 3 over 7.
Did you just cross multiply?
Yeah, 7x minus 21 equals 3x plus 3. And we're not finishing it from there. I mean, I think you can get it from there, right? Maybe? 4x is 24. X has to be 6. Okay. Let's switch over to this one. This guy.
Basically the same thing as the one above there.
Same thing as one above?
Basically. Except it's natural.
natural
log,
log.
not.
So what's that going to look like? So I'm going to have natural log, I mean, because it's the same problem, of 4, right?
No. Because it's -1.
Oh, yeah, you're right. I knew that. It's exactly, yeah. So it's 2, but still.
So it's going to be, because the e, you make it to the natural log of 2x minus 1. Is that what you did? No.
Change it to an exponent. That'd
Yeah.
be e what?
Squared?
Yeah.
Equals,
2x minus 1.
yeah. So you got e squared plus 1 equals 2x. E squared plus 1 over 2 equals x, whatever that is, to 3 decimal places. All right. Homework, yes.